Hello students, now we are going to start our next chapter of chemistry, chemical bonding and molecular structure. In this chapter we will study about various processes by which a molecule is formed from atoms and about its structure. Let us first start with Coulson-Lewis approach to chemical bonding. According to Lewis, atoms achieve the stable octet when they are linked by chemical bonds. To attain stable configuration or to complete octet, atoms combine with each other. These atoms combine either by gaining and losing of electron or by sharing of electron. And in this way, atoms completed their octet, that is, number of electrons in their outermost shell becomes 8. Number of electrons in outermost shells are also called as valence electrons. And according to Lewis, atoms can be symbolized by using their valence electron in the form of dot. Just like lithium can be represented by this symbol, as lithium has only one electron in its valence shell, so one dot with lithium. Beryllium has 2 electrons in its valence shell, or it has 2 valence electrons, so 2 electrons in the form of dots are represented with its symbol. Now Coulson suggested that when atoms come closer to each other and they have sufficient difference in their electronegativities, then one atom with lower electronegativity loses its electron and other atom with higher electronegativity gains that electron. And in this way, they get converted into cation and anion, and hence these two ions are bonded or joined by electrostatic force of attraction. This can be explained by taking example of formation of sodium chloride. Electronegativity of sodium is very less, or we can say that sodium is an electropositive element. So it loses its electron very easily and thereby converting into sodium cation. And in this way, sodium achieved stable gas configuration of neon. Chlorine, on the other hand, after accepting electron, converted to chloride ion, and also it achieves to stable gas configuration of argon. Now sodium cation and chloride anion combine with each other to give sodium chloride. Similarly, we can explain formation of calcium fluoride. Calcium, after losing 2 electrons, get converted to calcium plus 2 and it achieves noble gas configuration of argon. Fluorine, after accepting electron, converted to neon configuration, and in this way we get calcium fluoride. Okay. Now the bond formed as a result of the electrostatic attraction between the positive and negative ions was termed as ionic bond. Okay, or it can also be termed as electrostatic bond. Now in this way atoms can complete their octet, or we can say that atoms completed 8 electrons in their outermost shell. Now according to Coulson and Lewis, as we have discussed just now, that atoms either gain or lose electron or share their electron with other atom. So according to that, bonds between atoms may be of two types. One is covalent bond, where atoms share their electron with each other, and other one is ionic bond, where transfer of electron and gaining of electron takes place. Let us understand formation of covalent bond with the help of this example of chlorine molecule. Chlorine molecule contain 2 chlorine atoms. Okay. As we know that electronic configuration of chlorine is 1s2, 2s2, 2p5. That means in its outermost shell 7 electrons are present. Okay. So chlorine need 1 electron to complete its octet. So both chlorine atoms, they share their 1 electron, and in this way their octet is being completed. So we can say that 2 chlorine atoms in chlorine molecules are bonded via covalent bond. Similarly, we can show formation of water molecule. Formula of water is H2O, that we know. Configuration of hydrogen is 1s1. Okay. Configuration of oxygen is 1s2, 2s2, 2p4. So in this way, oxygen contains 6 electrons in its outermost shell. That means it needs 2 electrons to complete its octet. Hydrogen has only 1 electron in its octet and it needs 1 electron to complete its duplet. Okay. So in this way, one oxygen atom share 1 electron with 2 hydrogen atoms, and in this way oxygen get 2 electrons from 2 hydrogen atoms. Its octet get completed and hence it becomes stable. Both hydrogen atoms, as they need 1 electron, they share 1 electron with oxygen and get 1 electron of oxygen, and hence both hydrogen atoms also get stable. Formation of carbon tetrachloride CCl4. Configuration of carbon is 1s2, 2s2, 2p2. Carbon contains 4 electrons in its outermost shell. It needs 4 electrons to complete its octet. Chlorine outermost shell configuration is 3s2, 3p5. Means it contains 7 electrons in the outermost shell, as we have just discussed just now. So one carbon share its 1 electron with 4, and in this way each chlorine atom and carbon atom completed their octet and becomes stable. Okay. So when two atoms share 1 electron pair, they are said to be joined by a single covalent bond. If two atoms share 2 pair of electrons, then the covalent bond between them is called as double bond, and it can be explained by using formation of carbon dioxide with carbon and oxygen. Here carbon and oxygen share their 2 electron with each other, and hence they are bonded by a double bond. Similarly, formation of triple bond can be explained by taking example of N2 molecule. Configuration of nitrogen is 1s2, 2s2, 2p3. It contains 5 electrons in its outermost shell. Okay. So nitrogen need 3 electrons to complete its octet, and both nitrogen atoms share their 3 electrons with each other, and hence their octet is completed. Now in this way, when atoms bonded with each other by sharing of electron, then they acquire some charge as compared to their neutral state. This is known as formal charge. The formal charge of an atom in a polyatomic molecule or ion may be defined as the difference between the number of valence electrons of that atom in an isolated or free state and the number of electrons assigned to that atom in Lewis structure. Okay, so this is the difference between number of electrons in its valence shell when it is in neutral condition and number of electrons in its valence shell when it is in bonded condition. Formula of formal charge is this. Formal charge equals to total number of valence electrons in the free atom, means when atom is neutral, unbonded, minus total number of non-bonding or lone pair of electrons minus half of total number of bonding or shared electrons. Let us take some examples to understand this formula. This is ozone molecule. Okay. Now label these oxygen molecules by 1, 2 and 3 number. The atoms have been numbered as 1, 2 and 3. The formal charge on central oxygen atom marked 1 is 6. 6 is number of valence electrons in neutral state of oxygen atom. Minus 2. 2 is unpaired electron. See, these electrons are termed as unpaired electrons or lone pair of electrons. Minus half of 6 gives plus 1. 6 is number of shared electron for this oxygen atom 1. This oxygen atom 1 is sharing 6 electrons with oxygen number 2 and oxygen number 3, as it is making double bond with oxygen 2 and single bond with oxygen 3. Similarly, the formal charge on second carbon atom can be calculated and it comes out as 0. And formal charge on oxygen number 3 is -1. Okay. Now this +1, -1 and 0. These are the charges developed on each oxygen atom in ozone molecule as compared to their neutral state. So just now we have discussed that to complete octet, atoms combine with each other either by gaining or losing their electron or by sharing of their electron. Atoms combine with each other to complete their octet means they want to complete 8 electrons in their outermost shell. But there are some limitations of this rule. First limitation, the incomplete octet of the central atom. In some compounds, the number of electrons surrounding the central atom is less than 8. This is especially the case with elements having less than 4 valence electrons. For example, lithium chloride LiCl, BeH2 and BCl3. In BeH2, number of electrons in the valence shell of beryllium are 4. Okay, it's not 8. Again, in BCl3, number of electrons in valence shell of boron is 6. So it's not 8. But still these molecules are stable. So it is a limitation of octet rule. Second is odd electron molecules. In molecules with an odd number of electrons like nitric oxide NO and nitrogen dioxide NO2, the octet rule is not satisfied for all the atoms. Easily we can examine that whether nitrogen contains 8 electrons or not. Next drawback is expanded octet. In some of the molecules, it was found that number of electrons in valence shell of central atom are more than 8. For example, PF5. In PF5, phosphorus is central atom. It makes 5 bonds with 5 fluorine atoms. So in this way, in its outermost shell, it contains 10 electrons, more than 8. SF6, sulfur is the central atom, and since it is bonded with 6 fluorine atoms, so it has 12 electrons in its valence shell, again more than 8. Okay, so in this way, octet rule doesn't explain formation of these molecules. Now other drawbacks of octet theory is, it is clear that octet rule is based upon the chemical inertness of noble gases. As every element wants to achieve noble gas configuration, it wants to complete its octet. But it was observed that some noble gases, for example xenon and krypton, also combine with oxygen and fluorine to form a number of compounds like XeF2, KrF2, XeOF2, etc. So it cannot explain the chemical reactivity of xenon and krypton. This theory does not account for the shape of molecules. Third is, it does not explain the relative stability of the molecules, and it is being totally silent about the energy of a molecule. So this is all about this video in which I have explained covalent bond formation and octet rule. In the next video I will discuss ionic or electrovalent bond.